let's look at the argument again. The argument says that the statistics of V with the butterfly control and U are closed, right? That is basically a statement of the statistics of two solutions. However, there is a question whether the statistics of these two solutions would be representative of the statistics of the whole system. Well, if you remember our discussion on ergodicity, we already said that the time average of a function along the trajectory starting from almost anywhere would equal to the ensemble average, right? So almost any solution would have a statistics representing the whole system. However, the trick is almost. Almost everywhere means there might exist a measure zero or probability zero set of initial conditions over which the time average, right, starting from these very special initial conditions would not be representative of the time average starting from almost anywhere else. It would not be representative of the statistics of the system. These kind of special initial conditions leading to these special solutions are what we typically call non-physical solutions, right? For example, we all know that if you solve the flow field, if you solve a turbulent, supposedly turbulent flow field, right, of very high Reynolds number, you may be able to find a laminar solution, although unstable laminar solution, that is actually a steady state.
But
this is non-physical, right?
Yeah, but that's where we come to. Indeed, if you would use ergodicity, but can't you simply use what Dimitris said, that we have an infinity norm difference being small, and just use the definition of the infinite time average to say that, well, these two are close. If it is laminar, close to laminar. If it's turbulent, close to turbulent.
Yes, I'm going to explain that a little bit later. It turns out that there is a larger set of non-physical solutions, not just the non-physical. There is no black and white. Either it's laminar or turbulent. There turns out to be a set of what I call quasi-turbulent solutions that looks almost like turbulent solutions but are non-physical. So let me explain that. And
is it like periodic orbits and the like?
Sorry?
Is it periodic orbits or?
No, these are not just the periodic orbits. So let me explain it. Okay. So non-physical solutions. So it turns out that the shadowing solutions that actually satisfies the exact governing equation and stays close to the control system could be non-physical. And in some of the test problems I have dealt with, it's almost always non-physical. And let me explain why. Okay, so the non-physical solutions, they are a set of solutions starting from an unlikely or measure zero set of initial conditions whose time average differs from the ensemble average.